If you're seeing my screen, you see y equals 4. And
Yeah.
then here is kind of our like options here. So if y is 4 and we go with r sine theta, the only way that this is true is when when theta equals pi over 2 and r equals 1. R equals 4. I'm sorry. I guess there's some other possibilities here too, but for polar equations, there's a standard form for horizontal lines because that's what y equals. So this one, I have to I believe it's to look this one up actually. You end up dividing both sides by sine theta. So you get r equals 4 divided by sine theta, or sometimes written as 4 cosecant theta. And if you have that polar one up, like if you didn't have me available to help you today, you could graph this one. You'd have to type in theta instead of x, theta, but you will see that it does actually give you a straight line for that.
Okay.
All right, so let me move a little faster here, and I want to get through a bunch of these. So similarly, for vertical lines, x equals 10. So you're looking at 10 equals r cosine theta. So you solve for r. So you get r equals 10 divided by cosine theta, or 10 secant theta. That will also give you the same thing.
Okay.
All right. Where to go from here? So now the next ones are a little bit different. Next one says f of x, or we could even write y equals 3x plus 9. Okay. And if you recall, you have x equals r cosine theta and y equals r sine theta. So the approach here is you take these and substitute them in for x and in for y.
Yeah.
Okay, so we have r sine theta equals 3 r cosine theta plus 9, and you still want to solve for r. To do that, you move this term over here over to the left, r sine theta minus 3r cosine theta equals 9. Factor out an r, and then you divide. So this one doesn't really look all that nice. It's 9 over sine theta minus 3 cosine theta. You cannot do the reciprocal stuff that we just did. It just doesn't work here. So you know what the graph of 3x plus 9 looks like. It's some sort of line going up and to the right. So if you're to graph this, it should similarly look like that there.
Yeah.
All right. The next one. Next one here. I mean, this comes up so rarely that I don't remember some of the shortcuts here. I'm tempted to write this as x times x minus 7, but
yeah,
again, x equals r cosine theta, y equals r sine theta. And then if needed, it might be needed here, but x squared plus y squared equals r squared. I don't know if that's needed on this one. See, the thing is that you've got a y on the left side here. That's why I'm not particularly sure. If you divide both sides by x, y over x is x minus 7. You can substitute in for this because tangent of theta is y over x.
Yeah.
So this is tangent of theta equals x is r cosine theta minus 7. And again, your goal is to solve for r. So as long as you can isolate R, you can have a go at it. So this one, you would add 7 to both sides. Let me rewrite it. R cosine theta equals tangent theta plus 7, because you move it over. And then you divide both sides by cosine theta. So R equals tangent theta over cosine theta. Maybe that reduces, maybe it doesn't. 7 over cosine theta. Depending on your instructor, you whether you need to reduce or not, kind of. I would be okay with any of these possible ones.
Mm-hmm. Okay.
All right, so what to do next? Okay, so convert the following equations into rectangular form. So kind of see what your instructor is doing here, unless maybe they got this from someone else. I don't know. Sometimes these are harder. Sometimes they're easier. I don't make a judgment quite yet. This is the one that I'm kind of drawn to here. Problem is R is in the wrong place.
Mm-hmm.
But I believe if I were to graph this, I'm going to go ahead and graph this on mine and see if I can glean anything from this. Let's see, 10 cosine theta. So it's a circle. Yeah, it's really interesting. So R is X divided by cosine theta.
Okay.
And then okay, you put X over here, cosine theta equals 10 cosine theta. That's not great because X now equals 10 cosine squared theta.
Yeah.
So when I graph this, it's a circle that's just moved to the right.
Uh-huh.
Trying to figure out how to get you to that. So the other option here is you can square both sides. That gives you R squared equals 100 cosine squared theta. Why would that help? Yeah, so this must have been covered in class. Like it must, my guess is that somehow you were supposed, when you, with this problem right here, when it's in this form, you're supposed to know that it's a circle that's moved right. But how would you know that? That's kind of my question here. Like I can give you the answer, but I don't see the path there for it.
Yeah, there was like a page in our notes that's like if the coefficient is odd or even, and like it looks a certain way. If it's cosine, it looks like this. So there's some kind of cheat sheet I have.
Okay, well then maybe that's enough here, because the what this is it's a circle that's centered at 5, 0. So it's X minus 5 squared plus Y squared equals 25. And that's where I'm like struggling to like how to tell you that is what it is.
Yeah.
Maybe the intention was to graph some of these.
Yeah.
I'm not sure. So the next one, 3 sine theta. And this doesn't come up again, and it comes up again in calculus too, if you someday get there. But this is like a one-time like thing. Like nobody's gonna ever ask you in an interview, hey, you remember polar coordinates? Like, no, it's not.
Good.
Yeah.
I just
But
don't really
it
understand
is part of,
what is it?
so
Like, is it
it's a way of imagine if you could control motion with a direction and then a push.
okay?
Like you could take your sister or your brother, blindfold them, spin them around, and then push them. Like that's, you could describe, like we describe our world as, forward or, left, right, up, down, but in this world, it's only rotations and pushes.
Okay. Got it.
Now, why would you do that? I don't know, but that is the, that's what it is. There are problems in real life that are solved easier in polar coordinates, but nothing that, would really be practical to talk about here.
Yeah.
So whenever you see sine, it's a circle that's moved, it's up this way. And again, I think you're supposed to know this. I think you're supposed to realize that the center is at 0, 1.5 or 3/2. And the radius is also 3/2. Again, I'm not sure how you're supposed to know that other than like doing some of this. So this becomes x squared plus y minus 3/2 squared equals 9/4. And I'm using this equation, x minus h squared plus y minus k squared equals r squared.
Okay.
Okay, on to for tangent theta. Would you like me to snip in the graphs? I have not done that, but if it would help you, I
Yeah,
could.
that would be helpful.
All right, let me do that here. This one's a little hard to see. Of course, the one I finally suggest we do. Okay, so here's the graph. It's the red graph. Kind of looks like a Spider-Man thing. This one isn't as obvious to me, like what it is. It's not like the other ones, which were truly circles here. So I'm first reminded that tangent of theta is y over x. That could be useful. R is equal. I'm sorry. You can either go r x equals r cosine theta, y equals r sine theta. We could go with either of those. Okay. Now, if we go, how do we want to do this? If we think about tangent though as being sine over cosine, so let's go r equals 4 sine theta over cosine theta. If we want to get a cancellation, we have to be very careful with how we do this. We actually need r to be something over cosine. So we're going to choose this first one here and make it x over cosine theta equals r. So that's x over cosine theta equals 4 sine theta. Ooh, this one doesn't work out nicely. Okay. This one doesn't work out. So let's go back. I'm sorry, ran into a little snag here in this one.
Okay.
Let's see here. Let me try another.
Okay.
Something else here. Any chance there's a correction on this one?
Nothing that I can see, but
Okay, so here's what I found. You actually have to square both sides. So you get
oh,
r squared equals 16 tangent squared theta. And then r squared is x squared plus y squared. and then tangent of theta is y over x. So if you square both sides, you get tangent squared theta equals y squared over x squared. So said all that, this first one goes over here, x squared plus y squared equals 16 y squared over x squared. And now you got to solve for y-ish. So remember the graph went both up and down. It went part up and part down.
Mhm.
That's because it's so hard to solve for y here. So if you multiply both sides by x squared, you've got x to the fourth plus x squared y squared equals 16 y squared. Move this over here. So x to the fourth equals 16 y squared minus x squared y squared. Factor out y squared. So you get y squared equals 16 minus x squared. I'm sorry, y squared parentheses 16 minus x squared. And then you just move that over. So you get y squared equals x to the fourth over 16 minus x squared. And that's your solution. I mean, that's it.
Okay.
And I don't know how you would know to do that
Yeah.
unless you were told. The fourth one is exactly the same as the second one. So just put the same work down. That's 3 sine theta again. The last one, though, is 3 theta. R equals 3 theta. And this one is a spiral. Really interesting. So R equals 3 theta. The graph of this is kind of cool. Let's see if I can zoom out far enough to get you to get a decent picture of this. You see it starts in, goes out like that.
Oh, okay.
In terms of like, what do you do here? Yeah, not sure at the moment. Let me think about that here. So theta is the tan inverse of y over x. Would we do that for this?
I think so. I mean,
I think you do, but it's like you also so you really need to square the left side and the right side, so it's 9 theta squared.
okay.
And it's because then the left side becomes x squared plus y squared equals 9. And then it's the arctangent inverse y over x squared. And so you divide, you get rid of the 9, move the 9 over here. So you have x squared plus y squared divided by 9. And then you take a square root of that, which you really can't. So this is considered implicit form.
Mhm.
Boy, maybe your instructor did. So you can take a square root, but so when you take a square root of the left, it still is x squared plus y squared over 3, but there's a square root there. You just you cannot solve this for x. Like this is it. Like this is your final, this is all you can do here.
Okay.
And it's implicit, so it's got in terms of one variable and the other. Like you can't get a variable by itself.
Yeah.
Okay, does that take care of that, or is there more? Please don't be more. Okay.
That's all.
It's just not useful. I mean, really just isn't.
Yeah.
I mean, how does that help? I don't know. And you ask a good question, like when would you ever use this? I don't know.
Never.
Yeah,
Just
probably
have to
never.
learn it and forget about it.
Yeah. Okay, so the instructions here say to sketch, then calculate the components of the following vectors. So the vector is always the hypotenuse. So you can think of a vector going right and then up. So X and then Y. And then we already, it's not really polar form, but it's kind of related. X equals R cosine theta, which, and this is now R, but it's not, don't think of these as in being in polar form. So X is 30 cosine 45 and Y is 30 sine 45.
Mhm.
And these are nice numbers. It's 30 square root of 2 over 2. So it's 15 square root of 2. Same thing here on the right. It's 30 square root of 2 over 2. So it's 15 square root of 2. Um, 3 and 4 are identical
Okay.
of this. So I mean, I'll do them next, but I want you to see that they're really the same.
Yeah.
Uh, if you take a physics class, if you get an instructor that wants you to really like emphasize like vectors and stuff, they might be pretty difficult. They're useful, but just, there's a lot that goes on here. So this is X is 130 cosine 25. And then the answer is now in meters per second. I didn't put labels in the first one. I guess I should have. It's meters and meters. This does come up in physics quite a bit. We do need a calculator for these. Just make sure you check your mode, radian versus degrees.
Okay.
And I get 118 meters per second. Y is 130 sine 25 meters per second. .9 meters per second. Is that okay?
Yeah.
All right. 4 is the same. I'll go to 2 next.
Okay.
Maybe you can do 4 while I'm talking through 2.
Yeah.
So the only difference here is that you're going left. So you as a student, as a person that understands direction, you have to now assign that negative is left
Hmm.
and negative is down.
Yeah.
That is normal convention. You could certainly change it, but that wouldn't be recommended. Is that 50? Yeah, it is 50. It's still the same thing though. X is 50 cosine 23, but because you're left, I'm going to put a negative in front.
Okay.
That's it. There's nothing more to
Yeah.
that.
It's pretty simple.
Yeah. Are you, have you figured out college choice?
I'm going to University of Utah.
Fantastic.
Yeah.
And you've already got that all set up, accepted,
Mhm.
figure out. Great. That's Salt Lake. Is that right?
Yes.
Okay.
5 minutes away from my mom.
Well, she'll be happy.
Yes.
You may not be. Okay. We'll move through that. So sine is the other one. I've helped students at that school for a long time with math. They do, I mean, a good job. I mean, they're all kind of the same for math at least,
Good.
but there's obviously other stuff you can take there. All right. I don't know. I really don't think we should do any more of these. I mean, I think you can
They're
do
so
them unless you,
simple.
and then some time to do the completing the square
Yeah.
problems, which really aren't all that any more difficult, but they're worth looking at. Okay, so I'll go to practice problem number 1 for completing the square. All right, so completing the square, Matthew has his own approach. There are formulas for it. There's x squared plus bx plus c. My preference is to move this number over. X squared plus 6x equals -5. Okay, and then take half of this number. So this number is 6, so that's x plus 3 squared. And then the number that goes here is whatever this last number is squared. So plus 9. And then to be fair, you do it to the other side as well. So this equals 4. And you have like, I guess these problems don't suggest it, but are you solving or just completing the square to rewrite in vertex form? These kind of look like you're solving because it says equal
Yeah,
0. Do
I
you know?
think we're supposed to solve for x. Right?
Okay.
Yes.
That's generally what, but there's variations of this. So the next step here is to take a square root of both sides. So you get x plus 3 equals plus or minus 2, and then x equals -3 plus or minus 2, -3 plus 2, -3 minus 2. So that's -1 and -5.
Okay.
So the completing the square really isn't like that much a part of this, but it can get a little bit more complicated.
Yeah.
So we'll maybe see that in another problem here. I don't know. So number 2, it says x squared plus 8x, but I'm going to move the 9 over, and notice I leave a space.
Mhm.
So you take half of this middle number, so it becomes x plus 4 squared, and then whatever the last number squared is, that goes here. So plus 16 equals 25. Take a square root of both sides. So you get x plus 4 equals plus or minus 5. Move the 4 over. So you get x equals -4 plus or minus 5. -4 plus 5, -4 minus 5. So you get 1 and -9.
Okay. Not too bad.
3 is a small variation. So the variation on 3 is that there's a negative here. And all that does is change what you put into this binomial here. It becomes x minus 3 squared, half of 6, -6, -3.
Mhm.
And then when you square it, it is positive. So it's plus 9, plus 9. It is okay that it's 0 over here. Then you take a
Oh,
square root of both sides. So you get x minus 3 equals 0. Then x equals 3.
nice.
I guess I should just keep going through this. I mean, I was going to skip 4, but they're really pretty fast.
Yeah.
So you move the constant to the other side. You take half of the middle number. So in this case, plus 2 squared. Squared plus 4 equals 11. This time when you take the square root of both sides, it doesn't work out. It's not friendly friendly, so you just leave it like that. And then you subtract 2, so you get x equals -2 plus or minus the square root of 11. All right. Give me just 30 seconds, please.
Okay, no problem.
All right, I'm back. So number 5 is the only one actually that's got an odd number as the middle thing.
Uh-huh.
And that doesn't really change anything. It just makes it like less friendly. It becomes -5 halves squared because you
Yeah.
have to take half of it. So when you square it, it's 25 over 4. Okay, which means you have to change this number on the right to be also in 4. So this becomes 96 over 4 plus 25 over 4, which is 121 over 4.
Okay.
Which actually ends up working out nicely when you take the square root of both sides, because you take the square root of the top and the bottom, so it becomes plus or minus 11 halves. So x is 5 halves plus or minus 11 halves. 5 halves plus 11 halves. 5 halves minus 11 halves. So 16 halves minus 6 halves. So it ends up being kind of nice, even though you doesn't necessarily maybe look like it. There.
Yeah.
I'm going to skip 6, but I'm going to go to 7 because 7's finally different.
Uh-huh.
So there's a couple of ways to, it's like, this is where maybe formulas are better when you're doing a problem like 7. If you do the approach that I suggest, which is you move to the number to the other side, there is an additional step here. So the additional step is that you factor out the leading coefficient. Okay. And fortunately here you get a fraction, which isn't great. So it becomes x minus 1/2 squared, and then you bring this 4 down. So this part is the same as before, and then now there's the difference. The difference is you still take the square of this, which is 1/4, and put it here, but you have to distribute this 4 to each term to figure out what goes back in this previous line. So it
Yeah.
becomes plus 1, which is minus 16. Okay. And then you have to move this 4 over. So you get x minus 1/2 squared equals -4. When you take square roots here, you end up getting square root of -1, which is I. That's kind of a review. X minus 1/2 equals plus or minus 2i. So you get a complex valued equation, 1/2 plus or minus 2i.
Mm-hmm. Okay.
Eight is really, really awful. Are these all completing the square? Yes,
Yes.
they are. Okay, so 9x squared minus 12x plus equals minus 13. So this time, unfortunately, when you factor out a 9, you get you don't get anything good here. It becomes 12 over 9, which does reduce, but it's like the approach I'm showing you works really well when it's when it factors out nicely. Probably a formula would be better here, but and this reduces to 4/3, but I'll leave it like that for the moment. So now you take half of this, half of 12 over 9 is 6 over 9, or 2/3.
Mm-hmm.
So it becomes x minus 2/3 squared. You square it and put it back here. So that's 4/9 plus 4 plus 4 like that. And you bring the 9 down. So you get x minus 2/3 squared equals -1. Take a square root of both sides. X minus 2/3 equals plus or minus I. So x equals 2/3 plus or minus I.
Okay.
Nine and 10 get a little bit better. 4x squared minus 4x equals -5. Factor the 4 out. So you get x minus 1/2 squared. Always half of this middle number becomes this one down here. Bring the 4 down. Plus 1/4. When you distribute in, you get a +1, +1, +1, -4. I'm just combining these. Divide by 4, divide by 4. X minus 1/2 squared equals -1. Square root of both sides, just like the last problem. X minus 1/2 equals plus or minus I. X equals 1/2 plus or minus I.
Okay.
They're all the same. They're all the same, even though the numbers get weird or fractions, they're all the same. You just get it into this form, and then you take half of the middle term, and then you square it and put it back and move through it. It's not
Yeah.
exactly like a I mean, there's nothing exciting about this. I mean, I don't know why you need 10, but your instructor chose to give you 10. So this one's a little better problem because the middle term is 2. So when you cut it in half, you get x minus 1 squared. Bring the 4 down. 1 squared is 1. When you distribute in, it's +4, +4, +4. So it equals 3. Square root of or divide by 4. So you get x minus 1 squared equals 3/4. Square root of both sides. X minus 1 equals plus or minus the square root of 3/4, which is plus or minus the square root of 3/2, because the 4 is nice. Then you add 1 to both sides. So you get 1 plus or minus square root of 3/2.
Okay.
All right. We should go back and do, what did I skip? 6. Make sure we do that one. And then I
Yeah.
guess a couple more on the other one.
The
We'll be all done.
vectors.
Yeah. So 6 is, was it 6? Yeah. X squared minus 8x equals -15. You take half of 8. Then you square it, plus 16 equals 1. Take a square root of both sides. X minus 4 equals plus or minus 1. X equals 4 plus or minus 1. 2 equations, 2 answers. See, like this one you would solve by just traditional factoring. Completing the square is completely unnecessary here, but that is what they had you do. All right, so we did not do 4,
Yeah.
5, or 6, I guess. So we'll do 4 on that other one. Okay. So again, the drawing of it, you got 1 to the right here, 1 up. X is 300. Now this one's 22 east, so we actually need to get this angle here, which is 68 degrees.
Mhm.
So it's cosine 68 meters. I don't think I messed that up on any of the other ones because they were all sort of reasonable when I looked at them. But this one, make sure you change that, especially if it's for a grade. So this one is 112 meters. Y is 300 sine 68 meters. $278. They're both to the right and up, so they're positive.
Mhm.
All right, 5 is got Y going down. So this is 60 degrees south of east. So this is the 60 right here. So there's a couple ways you do. I guess I'll draw this triangle, right and down. That's 60 there. So X is 12 cosine 60. And then Y is 12 sine 60, but it's negative. So we're going to go down. Cosine 60 is 1/2. And then sine 60 is minus square root 3/2. So those work out a little nicer.
Yeah.
Last one. So your instructor's telling you that this angle right here is 79. So we're going to go left and then down, X and Y. So they're both negative. X is minus 77.4 cosine 79. Y is minus 77.4 sine 79. And then you just get those approximations here. We got minus 14.8 meters per second. Y is something a little larger, minus 76.0 meters per second. Right. Well, I think that gets us through everything.
Yeah.
Well, fantastic. If I don't hear from you again, I hope your graduation goes well, but maybe we'll do another lesson before then.
Yeah, I'm
But thanks
definitely
again for
gonna need
scheduling.
help.
Okay. All right. Well, thanks again for scheduling. I'll send you the notes here shortly and I'll see you next time.
All right. Thank you. Bye-bye.
Have a good night. Bye now.